Hello students, today we will discuss few problem on bounded set. Few problem on topic we have discussed earlier. What is that? Boundedness of a set, supremum, infimum of a set, upper bound and lower bound of a set. Now take a question 1. Give example of sets which are bounded, not bounded, bounded below, bounded above, but not bounded below, and bounded below but not bounded above. Give example of this. This is a question. Now what bounded example of a bounded set? Take a closed interval AB. Okay, closed interval AB, that is closed interval 1 and 2. 1 and 2. Then closed interval 1 and 2 is a bounded set because this is a set which contain all a real number between 1 and 2, including 1 and 2. 1 is also included in the set and 2 is also included in the set. So this is one example of closed. This is one example of bounded set because it is bounded below as well as bounded above. Open interval is also a bounded set. Minus, take one interval, open interval minus 1, 1. Okay. Now, in this interval, it is a set which contains all real number between minus 1 and 1, which do not contain minus 1 and 1 itself, but all other real number between minus 1 and 1. So, open interval is also an example of bounded set. Why? Because it is bounded below with minus 1 and bounded above with 1. Consider another set S1, which is 1 by n. N is a natural number. N belongs to n. N is a natural number. N is equal to 1, 2, 3, 4, etc. So it is a closed set, it is a bounded set or not bounded set, unbounded set. Now let us check. 1 by n. N is a natural number. 1 by 1. We will put in place of 1, 1, 2, 3, 4, etc. up to infinity. Okay. So, 1 by 1, that is 1. 1 by 2. Then 1 by 3. Then 1 by 4. Then 1 by 5, etc. 1 by n. When n tends to infinity. Okay. So this is a collection of infinite number of element. This is a collection of infinite number of element. But the largest of all these element is 1. Largest element is 1. And what is the smallest element? Smallest element we get when n become larger and larger. 1 by 10 is bigger than 1 by 100, is bigger than 1 by 1000. So when n is bigger and bigger, the number approaching towards 0, it becomes nearer to 0. So 0, but it is never 0, and also no element in this set S1 is, no element in this set S1 is, it is less than 0. Okay. So 0 is a lower bound. Obviously 0 is a lower bound. 1 is an upper bound. Hence what we get? S1 is bounded below by 0 and bounded above by 1. And the upper bound 1 belongs to the set, but the lower bound 0 does not belong to the set. We say like that. The lower bound 0 does not belong to the set. So S1 is an example of bounded set. Take S2. Okay. It is a finite collection. 1, 2, 3, 4, 5. It is obviously bounded. Any finite set is always bounded because it has the smallest element and the largest element. It is bounded below by 1 and bounded above by 5, and both belongs to the set. So S2 is example of a bounded set. So what we conclude here? Any finite set is bounded. Now we have discussed the boundedness of this set, boundedness of this and this. Okay. So these are example of bounded set. Now few example on unbounded set which are not bounded. Set of real number R. Set of real number R. Set of real number R moves from minus infinity to infinity, so it is not bounded. Below, neither it is bounded, above, so it is unbounded. Set of rational also unbounded. Set of integer also unbounded. What about set of natural number? We will consider in the next example. Bounded below but not bounded above. Bounded below but not bounded above. Consider the set of natural number. Set of natural number has an element 1, which is the smallest natural number. No natural number is less than 1. So 1 is the smallest one, so it is a lower bound of the set. So 1 is the lower, so it is bounded below. But natural number is unbounded above because we move towards infinity. Starting from 1, 1, 2, 3, 4, 5, 6, it never ends. So it is infinite collection and it is up to infinity. Hence it is not bounded above. So set of natural number is an example of bounded below but not bounded above set. Okay. It is a set which is bounded below but not bounded above. Set of natural number. Also we can construct another set S such that n square. N belongs to n. N is a natural number and n square. So what will be the element of this set? 1 square, 2 square, 3 square, 4 square, etc. So that is 1 square, 2 square, 3 square, okay, 4 square in this way. Now look at this collection. This is also an infinite collection and it has a lower bound 1, but it is unbounded above. So it is also an example of a bounded below set but not bounded above. So the upper boundary does not exist. There does not exist any element k such that all elements are less than or equal to that number. No. So we cannot find such a number k. Hence it is not bounded above but it is bounded below because 1 is an element such that every other element is greater than or equal to that. So these are example of bounded below but not bounded above set. Now consider bounded above but not bounded below set. Consider the set of negative integers. Set of negative integers. Okay. So that is bounded above but not bounded below. Bounded above by 0. Okay. And 0 is not included in the set, but it is the upper bound of the set. And all other negative integers are smaller than 0 and it moves up to minus infinity. Hence it is not bounded below but it is bounded above by 0. Okay. Consider another set. S is minus n cube such that n belongs to n. Minus n cube. Also you can take minus n square. Minus n. Okay. Negative natural numbers. It is the set of negative integers. We have taken minus n square, n cube. Okay. Anything. N square. Minus of n cube. Now n belongs to n. 1 cube, 2 cube, 3 cube, 4 cube with negative sign. Negative sign is outside the cube. So we get negative numbers. Negative numbers. And you can check that it is bounded above but not bounded below. Bounded above with minus 1. When n is equal to 1, it is minus 1 whole cube, that is minus 1. When n is equal to 2, it is minus 8 in that way. So it is bounded above by minus 1 but not bounded below because it moves up to infinity. So there is no lower bound. Okay, so these are example of bounded above but not bounded below sets. Now take another question. This is the question we have discussed about boundedness of a set. Bounded above, bounded below, bounded set. Now come to another question. Question 2. Find the supremum and infimum of the set. And also check which one belongs to the set. The set are given 1, 3, 5, 7, 9. This is a finite collection. 1 by n. N belongs to n. We have already discussed that it is a bounded set. Okay. Minus 1, minus half, minus 1 by 3, minus 1. It is minus 1 by n. N belongs to n. Okay. It is minus 1 to the power n by n. N belongs to n. We will consider each set one by one and discuss about its boundedness and what are supremum and infimum of the set and whether they belongs to the set or does not belongs to the set. Also few more examples. The study material is given and you can check the answer is there. We will discuss one or two problem here. Okay. So first one, answer 1, 3, 5, 7, 9. It is a finite set and 1 is the least element and 9 is the greatest element, such that all other elements of this set are greater than 1 and all elements are less than or equal to 9. So all elements lies between 1 and 9. So 1 is the least member and 9 is the greatest member. So infimum is 1 and supremum is 9 and both belongs to the set. Consider another set. Second one. Minus 1, minus a half, minus 1 by 3, minus 1 by n. This is minus 1 by n. N belongs to n. This is this set. No. Okay. Now the element move towards 0 and starts from minus 1. So all elements lies between minus 1 and 0. Okay. But however large the denominator is, it does not become 0. It moves very close to 0. Hence we can say that 0 is an upper bound, but that does not belongs to the set. Hence supremum of, so this is the largest element 0. The supremum is 0 and does not belongs to the set. We say that supremum is 0, it does not belongs to the set. And infimum is minus 1 and it belongs to the set. Because minus 1 is the smallest element. All other elements are greater than or equal to minus 1. So minus 1 is infimum and 0 is the supremum. 1 belongs to the set and 0 does not belongs to the set because it does not become 0 exactly nowhere. Okay. So 0 does not belongs to set. It is approaching 0 only. Consider this one, 1 by n. Okay, this set can be written as 1 half 1 by 3. It also moves towards 0. Okay, so but the largest is 1 and smallest is 0. So here supremum is 1 and infimum is 0. Supremum is 1 and infimum is 0. And the infimum does not belongs to the set, but the supremum belongs to the set. So in this way you can check the supremum and infimum of other sets.